So you can't talk about solutions without talking about concentration. And the concentration is the amount of the solute that's in the solution. And we're going to look at 4 different ways to measure concentration. We can measure mass over mass, which is grams over grams. We can measure a volume of solute in a volume of solution. We can measure the mass of a solute in a volume of solution. And finally, the chemist's favorite, we can measure molarity, which is the moles in a liter. So we're going to look at each one of these individually so you'll be really comfortable with them. The first one we're going to look at is mass percent. Mass percent is the mass of the solute divided by the mass of the solution times 100%. So let's look at a couple of problems. If we have 42 grams of water added to 8 grams of potassium chloride, making 50 grams of solution, what is the mass percent concentration? So we need the mass of the solute. That's this 8 grams. So we'll say 8 grams. We're going to divide it by the mass of the solution. The mass of the solution is 50 grams. Times 100%. And that gives us a 16%. And we'll want to put mass over mass solution of potassium chloride. So let's look at the second problem. What is the mass percent of sodium hydroxide in a solution prepared by dissolving 30 grams of sodium hydroxide in 120 grams of water? So the mass of the solute is the sodium chloride. Remember, the solute is the one that you have less of. So we've got 30 grams. And then we need to divide that by the mass of the solution. Note here that the solution, the mass of the solution, is going to be equal to the mass of the sodium hydroxide, and the mass of the water. Okay, so we're going to have to add those together. So the denominator will be 30 plus 120. This will be times 100%. And we'll get in our calculator, and we'll get 20%. And we'll put how it was measured, mass over mass, and it's as sodium hydroxide. So that's mass percent. Let's look at volume percent. It's very similar to mass percent, except that we're going to put the volume of a solute over the volume of a solution. So here we have a bottle that contains 59 milliliters of lemon extract solution. If the extract contains 49 milliliters of alcohol, what is the volume percent of the alcohol in the solution? So the 49 milliliters of alcohol is going to be our volume of the solute. So we'll have 49 milliliters, and we'll divide that by the volume of the solution. And we have up here 59 milliliters of solution. So we'll put the 59 on the bottom. We'll have to do times 100%. And we get that our lemon extract is 83% alcohol. What is the volume percent of bromine in a solution prepared by dissolving 12 milliliters of liquid bromine in a solvent carbotetrachloride to make 250 milliliters of solution. So we'll have our 12 milliliters of bromine, and we'll put it over our 250 milliliters of solution times 100%, and we'll get 4.8%, and we'll want to put volume to volume, and we'll put bromine. Mass per volume. Okay, this is actually one we use quite a bit in lab. What is the mass percent volume of a sodium hydroxide solution prepared by dissolving 12 grams of sodium hydroxide in enough water to make 220 milliliters of solution? So what we're going to be doing here is putting the mass of the solute, dividing it by the volume of the solution times 100%. The mass of the solute is 12 grams, and the volume of our solution is 220 milliliters times 100%, and that will give us, turn the page over here, 5.5%, and we'll write volume to mass sodium hydroxide. That's the first three. Let's look at how we can use percents as conversion factors. So if I say 7% mass per over mass, that's the same as saying that I have 10 grams of solute in 100 grams of solution. So we're writing an equality, and then we can use that equality to write these conversion factors. 7 grams over 100, 100 over 7 grams. This is the same as when we were doing conversions in one of the first chapters. If I have 12% volume to volume, that means I've got 12 milliliters of solute in 100 milliliters of solution, and I can write these conversion factors, and so forth. So let's look at these problems. How many grams of sodium hydroxide are needed to prepare 75 grams of 14% mass over mass sodium hydroxide solution? So what we have, they've given us, is that we've got 75 grams of a solution. We want to know how many grams of sodium hydroxide are going to be required. We can use this 14% to write an equality. And our equality will say, this is mass over mass, it'll say that there's 14 grams of sodium hydroxide is found in 100 grams of solution. That equality came right from that number right there. That's where that came from. Make sure that you can see that. Okay. So now I'm ready to write my problem. I'll write 75 grams of solution. And then I'll draw my line. And then I'm going to use the equality here to write a conversion statement. I want grams of solution in the bottom, so we'll put 100 grams down in the bottom of solution, and we'll put our 14 grams of sodium hydroxide in the top. We'll do our math here. We will get 10.5 grams of sodium hydroxide. Note that solution, grams of solution cancels, and that leaves us with grams of sodium hydroxide. So this is a conversion, just like we did other conversion statements. A topical antibiotic is 1.1 mass per volume clindamycin. How many grams of clindamycin are in 60 milliliters of this 1% solution. Okay, so we can write from using this, we can write an equality that states that 1 gram of clindamycin, I'm just going to abbreviate that with a C, is equal to 100, and this is a volume, so it'll be milliliters of the solution. In this case, it's kind of a cream. Okay, so we've written our equality. We're starting with 60 milliliters of the solution, and we'd like to know the grams of clindamycin. Abbreviated that with a C. So we'll write 60 milliliters of solution, and we'll draw our line. We're going to come up here to this equality, and we're going to put the 100 milliliters of solution on the bottom, and our 1 gram of clindamycin on the top. Now we do our math on this, we'll get 0.60 grams of the clindamycin. How many grams of morphine does a patient receive if 0.6 milliliters of a 2% solution is ordered? So we get 2 grams of morphine in 100, then we're doing in volume milliliters of solution. So we can start with our 0.6 milliliters, 0.6 milliliters. We'll want to use our conversion statement. We'll want to put the 100 down here, and we'll want to put our 2 grams up here. And we'll get 0.012 grams of morphine.